Water, one of our most valuable resources. It provides life and enriches our lives in so many ways. We simply cannot grow and prosper without it. Since the early days of the West, the people that have settled in this arid land have always had to contend with the scarcity of water. And this has given rise to remarkable innovations and breakthroughs in water conservation to meet the rising demand. However, as our communities have continued to experience tremendous growth, storing an adequate supply of water has become increasingly difficult. Recent droughts have only compounded the problem by forcing us to severely restrict usage. Therefore, in order to provide enough water for our growing communities, we need to develop new solutions to store large amounts of water as efficiently as possible. Today, there is an economical and environmentally sound solution that builds on proven engineering and construction methods: the Porosity Reservoir. The Porosity Reservoir is an underground water storage system located in shallow alluvial sand and gravel deposits. It is completely separated from existing underground water flow and therefore does not affect surrounding water rights. In addition, the surface of the ground is still available to use in numerous ways. Benefits include: the period for implementation is measured in months, not years or decades. Does not interfere with surrounding water rights. Does not require an environmental impact study. It's scalable to meet your needs. Maintains permanent dominion and control of the water. There are no evaporative losses. Future water storage is not limited to commercially mineable aggregate sites. Your storage capacity is not limited to local aggregate consumption. And since your water does not mix with other water sources, it will be there when you need it. Successful porosity reservoirs demand the finest design, development, and construction services. PS Systems is a leader in developing patented underground water storage systems. They provide complete porosity reservoir systems from site selection to implementation with operational guidelines and ongoing consultation services. Their projects maintain complete dominion and control of the water without eliminating surface use of the land. The first step to building an underground porosity water reservoir is to gather existing geologic information from both the state and federal levels. Maps are reviewed to determine potential locations for reconnaissance, followed by site visits. This is an example of an actual site involving one section of land, or 640 acres of surface area. The ground is first analyzed using surface geophysics with techniques commonly used for energy and mineral exploration. These techniques provide the first view of the underlying stratigraphy to confirm the preliminary site data. The geophysics data has identified a potentially good site encompassing 402 surface acres for additional analysis. Next, test hole sites are identified to provide an accurate representation of the subsurface. From the test holes, field sample laboratory tests will be performed to determine gross and net porosity and drain-down performance. Bedrock samples are also tested for competency and compatibility with slurry wall construction. Next, hydrophysical analysis is conducted to determine water flow characteristics, water quality, water compatibility, transmissivity, and specific capacity. From this information, approximate water storage capacity and water flow characteristics are estimated. At this time, the decision is made whether the site is acceptable or not. If the site meets the development criteria, and the engineering and construction process moves forward. Initially, the infrastructure for filling and emptying the reservoir is designed to meet the needs of the end user's water rights. The exterior mitigation system is also designed to maintain historical gradient of the existing alluvial flow. The next step is to separate the identified alluvium from the underground water flow system. The slurry wall is the best method because of its environmentally favorable attributes and reliability. A slurry wall is made of 100% natural material, does not wear out, is self-sealing, and only has temporary surface disruption during construction. Once the slurry wall is constructed, the reservoir is now hydrologically invisible to the surrounding alluvial water flow. The water that is trapped by the slurry wall belongs to the river system and is pumped back into the river. The reservoir is then filled and drained to determine actual capacity. It's also tested for leakage to meet the stringent standards of the end user and any regulatory agency involved. When all the development and construction is finished, A completely isolated alluvial deposit covering 402 surface acres at an average depth of 58 feet will exist. This deposit will have a storage capacity of approximately 4,500 to 5,000 acre-feet of water, the equivalent of serving 9,000 homes over a period of 1 year. And this reservoir is not affected by evaporation loss or surrounding water rights issues. It's your water to use as you need it.